Okay, so now we're going to start science. So make sure that you have your science book out and your vocabulary notebook out. You can also go ahead and have your packet because you will have some independent practice and some homework. Excuse me. But you don't need that out just yet. But you do need your science book, and then you need your vocabulary notebook opened up to a clean page in the science section. Make sure you're in the science section. And remember, you can use the backs of pages so that we don't use it all up. Just make sure you're on a clean page. So today's lesson is going to be on Chapter 9, Lesson 2. So go ahead and open up, excuse me, go ahead and open up your textbooks to page 420. And, excuse me, then look at the look and wonder box. This is something you're going to do in your head, not out loud. Well, I mean, you can do it out loud if you want, but it's going to be in your head. Building a house is no simple task. It takes planning. Every material that is used for the house must be measured. How does a builder make all those measurements? So what I want you to think of is that. Well, not only do they need the wood, but they need bricks, they need concrete, they need tile, they need countertops, they need so much. But before you can even start building, you have to know how much of most of those things you need. So they want to be able to figure that out as quickly and as soon as possible. And so today we're going to talk about different ways that we can measure matter. We've been talking about matter, so now today's lesson is on how we can measure that matter. So go ahead and turn the page and make sure that you're reading along with me as I read out loud. Make sure we're in full screen and take breaks, short breaks, not really long ones, but take short breaks when you need them. So first I want you to look at the main idea on that bookmark at the top of page 422. It says, matter can be measured in standard units of length, area, volume, mass, density, and weight. How do we measure matter? Measuring and counting squares is one way to compare size. When we measure, we use standard units. A standard unit is a measurement on which people agree. We can't just make up our own units. Otherwise, if you tell somebody at the grocery store that you need 3 packages of apples, but all they know is 3 pounds of apples, you're not going to be able to figure out what the other person means. Many people in the United States use standard units in the English system. The inch, pound, and ounce are standard units in that system. Now that's not what everybody uses, but that's what we in the United States and a couple other countries use. Scientists use standard metric units. The metric system is based on units of 10. So this is a different system of measurement than what we use. We do see these, and you've probably heard of most of these, but we mostly use the English system, whereas this is the metric system. So our first word is metric system. And the metric the metric system is units of measurement. Let's see. Units of measurement, or well, we'll say standard units of measurement based on units of 10. And we'll talk a little more about what that means in just a minute. It uses prefixes. Remember, we learned a prefix is letters that go at the beginning of a word to kind of change the meaning. It uses prefixes such as kilo, centi, and mille to define the size of measurements. For example, 1 meter meter is the base word. 1 meter is divided into 100 centimeters. There are 1,000 meters in a kilometer. So let's look at this diagram at the bottom of page 422. Make sure you're paying attention to this because you may see it in a little bit. So on this, in this diagram or this table, all the way on the left we have the metric units. We have 1 centimeter, 1 decimeter, 1 meter, and 1 kilometer. And in the middle we have the amount. So meter is the base word. So those prefixes centi, deci, and kilo tell us what that means, how that changed that word meter. So 1 centimeter is 1/100th of a meter, because the prefix centi usually means 100. So we'll put that here. The prefix centi usually means 100. So that means a centimeter is 1/100th of a meter. That means if you take that meter and you break it into 100 little pieces, 1 centimeter will be one of those 100 pieces. A decimeter is the same as 10 centimeters, or 1/10 of a meter. So if you take that meter and you break it into 10 pieces, 1 decimeter is going to be 1 out of those 10. Because the prefix deci usually means 10. If you take 10 of these centimeters, you would have 1 decimeter. So if you're confused on this, just look at the this diagram will help you. Then we have a meter. That's the base word. That's the base measurement. 1 meter is, of course, 1 meter. It's also equal to 10 decimeters and 100 centimeters. A kilometer, kilometer, it's different, depends on where you are, how you say it, but 1 kilometer is the same as 1,000 meters, because the prefix kilo or kilo is usually used to mean 1,000. So that means 1 kilometer is 1,000 of those meters. Now you're going to have to kind of look to figure out, okay, centimeters and decimeters are smaller than a meter. Kilometer is larger than a meter. So if it's smaller, that means it is a piece of that meter. If it is larger, that means it is multiple of those pieces put together. So let's answer this question underneath read a table. It says, how many centimeters are in a meter? Well, if we look at this table and we find a meter, we can look and we see 100 cm, and cm is the abbreviation for centimeters. So that means there are 100 centimeters in 1 meter. Now, this is where it's going to be tough, because we have to figure out, oh, well, never mind, I'm sorry, the book tells you. Then it wants to know how many centimeters are in a kilometer. So let's go down to the kilometer and let's see if it tells us. And we see where it says 100,000 cm. So that means there are 100,000 centimeters in 1 kilometer. Now if we turn the page and look at page 423, let's start reading at the top. Length and width. An object's length is the number of units that fit from one end to the other. So that's our next vocabulary word. I'm going to go ahead and erase these, make sure that you already have them written, and then I will go ahead and erase them because we need room for our words. So our next word is length. Length is the number of units that fit an object from one end to another. So length is the number of units that fit in an object from one end to the other. is the number of units that fit across. So not from one end to end, but if you have a, say you have a pencil. Here's the eraser. Here's the tip. The length is from here to here. That's how many objects fit across. If we wanted to do the width, that's how many, that's how many units fit from one end to the other. The width would be this right here. Be measuring across this pencil. Now, it would be really hard to measure the width of a pencil, but that's the first thing that came to my mind. So you would normally measure the width and the length of something larger. So then if we look at our textbook, we can kind of take a guess based on what we know about rulers about how wide and how long it is. If we want to measure how wide, we're going to go from end to, if we want to measure the length, we're going to go from the beginning to the end. And I'd say this may be about a foot from here to here. And then if I want to go across to measure the width, I would measure from here to here, and I'd say maybe about 1.5 feet. Now that is an estimate. It's probably not exactly that, but that's about the length, which is from end to end, and the width, which is across. So let's look at these crayons at the bottom of page 422. So they told us you can measure length in centimeters or inches. So centimeters and inches are those units. And when we want to measure the length, we want to go from one end to the other. So from the pointed end that you draw with to the flat end on the back, in that red crayon is about 10 centimeters. That means that 10 of those little units, the centimeters, can fit from one end to the other. The green crayon is measured in inches. And there's about 4 inches that can fit between the pointed end and the flat end. They're about the same. 10 centimeters and 4 inches are about the same. It's about their equivalent or close to equivalent. Just like we talked about how fractions can be equivalent, measurements of length can be equivalent, but you just may need a different measurement depending on where you are, what you're doing. It may be better to say how many inches rather than how many miles. Like say you wanted to, miles are massive. Say you wanted to measure how many inches were between 2 people who are standing across from the room from each other. Would it be better to measure in inches how far away they are, in feet, or in miles? Well, you definitely don't want to do miles because miles are huge. If they're just standing on one end of a room and another, there's probably not even half a mile or even 1/4 of a mile between them. So it wouldn't be realistic to measure them in miles. Inches might be a little too small. You'd have to take a ruler like this, or even a meter stick, and measure it from end to end over and over and over again. But then that would be a really long time to measure in inches. You'd have a really high number that you'd have to remember and multiply and all that. Whereas feet, you could do that really easily. Just measure it from end to end, and feet would probably be the best way. Now, if you were going on a trip to Nashville, you would want to know how many miles are between Memphis and Nashville. How many inches would seem like it would take years and years and years? Even though there is a number of inches that's the same as the number of miles, inches is going to be hundreds of thousands. And that's not really going to help you to figure out how long it will take as much as knowing the miles. Even feet. There would be way too many feet to measure that. So there are certain units of measurement that are better for some things than others. Even though you can get that they're the same. Like 10 centimeters is the same as 4 inches. But if you're getting into those larger units, there are better ones to choose. Area. Area describes the number of unit squares that cover a surface. An easy way to find, that's our next word. I'm going to go ahead and erase this pencil. And our next word is area. And area describes the number of unit squares that cover a surface. Okay? Now the difference between length, width, and area is this. So say I have a rectangle. The length would be from end to end. Go ahead and draw this in your notebook. You can do that right under area. The width would be how long it is across. So this is where we would just have 1 unit, 2 units, 3 units, 4, and we would measure how many units it takes us to get from one end to the other. The same with width. We would just figure out how many units fit between here and here. Now, area is where you take your square units. Like, remember we talked about this with square miles, where we said, you have this and it's 1 mile, 1 mile, 1 mile, 1 mile, and this whole thing is 1 square mile. Well, that's the same thing with area. That's measuring area. So we would see how many of these units would fit across and cover this whole shape. So I would keep drawing these little boxes or keep measuring with these little boxes until I covered the whole shape. So that's the difference between length, which is from end to end, width, which is across, and area, which is how many of those square units cover that whole surface. An easy way to find the area of a rectangular shape is to multiply the length times its width. So, instead of having to cover this whole shape with squares that measure exactly the same and count it, we can just multiply this length by this width because it makes an array. Think about it. An array is how many are the rows and the columns, and then you multiply them together. So if we have, this is not accurate because this is much bigger. If we have 7 inches of length and 5 inches of width, that means there are 7 columns and there are 5 rows. So to figure out how many that is in all, we would multiply 7 times 5, which means the area of this rectangle is 35 inches, 35 inches squared, because we're saying square inches. So that's how many of those little square inches, like this square mile, just imagine it as inches. That's how many would fit inside this object. The area of this page, for example, is 27 centimeters by 20 centimeters. That means, I think they're talking about just one page. From here to here is 27 centimeters. So if you took a ruler and you measured from the top to the bottom, you'd have 27 centimeters. If you took a ruler and measured across, you would have 20 centimeters. So to figure out the area of this page, we would multiply 27 by 20, 27 by 20 to get 540 square centimeters. So that means 540. If we took paper and we cut it up into a bunch of little pieces that were each 1 centimeter the whole way around, they were perfectly 1 centimeter the whole way around, that means we could fit 540 of them and cover up this page. Now, what if a shape is not rectangular? You would divide it into smaller squares. Find the area of each smaller shape. you might need to estimate parts of some shapes. Then add the area of each smaller shape to find the total area. So what that means is not everything that we need to find the area of is a perfect square or rectangle. Sometimes, like say you just moved into a new house and you wanted to figure out the area of your backyard. You have to put grass down. So you need to know how much sod you need. And your backyard looks like this. You can't just take the length and width. So what you have to do is you have to break it into smaller pieces that are rectangles or squares. So now we can take the length of this, so from here to here, we'll say it's 20 feet. And then from here to here, we'll say is 10 feet. That means 20 times 10, the area of just this piece is 200 feet squared. Because remember, we're square feet. That means 200 boxes that are each side is, 1 foot, 200 of them can fit. Now, that still doesn't tell us how much grass we need. That only tells us how much grass we need, how much sod we need for this part. So now we also have to figure out this part. So we've measured, and we know that from here to here is 30 feet. And from here to here, because we're not going to keep going, because we've already measured this part. So from here to here is 5 feet. So now we would figure out the area in here. 30 times 5 equals 150 square feet. So now we know for this part of the yard we need 150 square feet of sod, and for this part of the yard we need 200 square feet of sod. So that means now to figure out how much we need altogether, all we're going to do is add these two numbers. 200 plus 150 is 350 square feet of sod. So now we can go to Home Depot and say, hey guys, I need 350 square feet of sod for my backyard, and they can get it together for you. Sometimes what they say is you will have to estimate. Like say your backyard does, and then that. I don't know. You have like a little side path through gates. I don't know. I just started drawing. So say your backyard looks like this. Well, you're probably going to have to estimate for these two parts because they are a weird shape. You still can't get a perfect square or rectangle out of that. But that happens sometimes. And then you just estimate and you do the same thing. You estimate about how many feet and you try to, you just try your best to get the exact amount. Now, volume is the next thing. Volume describes the number of cubes that fit inside of an object. So not the number of cubes that cover, not the number of cubes that fit from end to end or across, but the number of cubes that fit inside. Let's add that as a vocabulary word. Number 4, volume is the number of cubes that fit inside an object. Now the reason that they said cubes instead of unit squares is that not only do we have to figure out, okay, there's 1 inch by 1 inch by 1 inch by 1 inch, that's 1 square inch, we actually have to do a cube. Bear with me. And each of these sides, 1 inch, 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 plus all the ones you can't see all have to be 1 inch. Now I realize that's really, really small. Hopefully you can zoom in or you're watching this in full screen. I'm so sorry. So the cubes is an actual, this is just a square, a flat square. that we just have to measure the sides and the length. For a cube, that means every single bit, it's 3D, and every single edge that you see has to be the same length. To find the volume of a rectangular solid, just multiply its length by its width and height. So a rectangular solid would be something like a cereal box. We have a cereal box. Now it's a 3D object, not just like a backyard, which we're just measuring the flat. And it's Cheerios. So to figure out the volume, how many of those cubes fit inside, we would take the length, the length, multiply it by the width, that's from back to front, and then multiply it by how tall the box is. So here's height, length, and width. So say we have 2 inches wide, 5 inches long, and 10 inches tall. We would say the height is 10 times the length, which is 5, times the width, which is 2. And now this is where, remember when we did math, we couldn't multiply 3 at once, so we're just going to use the associative property to group them. 10 times 5 is 50. Bring down times 2. That means that this box is the volume is 100 inches cubed. Cubed is a 3. Squared is a 2. Cubed is a 3. If a solid is not rectangular, like say you wanted to measure the volume of this cup, you want to know how many of those cubes will fit inside of this cup, you can use water. First, you're going to measure the amount of water in a larger container. So I would take a big empty pot, and I would measure how much water is in that container by actually looking at the side. I would mark where the water level is. Then I'm going to put this cup inside and see how much the water level has changed. So I'm going to submerge the entire object below the water. Then I'm going to subtract the water level I started with, from the new water level. So once this is in there, I'm going to have my water's going to go up. So that's going to be larger. So I'm going to subtract that original amount of water from the new amount of water. The result is the volume of that object. Now usually if you would do that, it would be something like if you want to know the volume of a rock. You could measure the amount of water in a measuring cup, put that rock inside the measuring cup, then subtract the original amount of water from the amount of water that's in there with that rock in there. To find the volume of a liquid, you pour it into a measuring cup, or a spoon, or a beaker, or a graduated cylinder. Then read the markings on the container. So usually if we're trying to find the volume of liquid, that's a lot easier than trying to find the volume of a solid object like a box or something weirdly shaped like a rock. Because all you have to do is get a measuring cup and then measure how much water is in there. If we look at these pictures at the bottom and top of page 423, both of these pictures give us examples of how to measure the volume. We can use kitchen tools to measure the volume in teaspoons or tablespoons. Those, if you have a small amount of a liquid or a powder or something like that, you can use a tablespoon or a teaspoon. If you have a larger amount of liquid or powder or maybe small fruits, you might use a measuring cup to measure volume in cups or pints. It's just like when we were talking about measuring length and width. For smaller things, you're going to use a smaller unit of measurement, and for larger things, you're going to use a larger unit of measurement. Let's look at the quick check at the bottom of page 423. Now, this is where you are I'm going to ask the question, You're going to pause, write the answer in your notebook right below your definitions, and then play it, and I will tell you the answer so you can correct it. Please make sure that you are answering the question before you watch my answer. So the first one, problem and solution. How can you measure the area and volume of your room? So what I want you to do now is I want you to pause this video, answer that question in your own words, and then play it and you can check your answer. Okay, the answer. To measure the volume, the area and volume, excuse me, to measure the area of your room. First, let's draw a picture. Is you would look at your room. Oops. And you would measure the length and the width. Now this is as if you are looking from above down at the floor of your room. So the width, like here's your bed, and your dresser, and your bookshelf, and whatever else you have is around there. This is if you are looking down, so you're going to measure the width and the length. Now, to figure, and then you would multiply those. Length times width would equal the area of your room. Now, if you want to measure the volume of your room, you would take this answer and multiply it by the height. So that means if you are looking at the wall in your room, here's your window, here's your bed with your pillows, and here's the door to the rest of the house. The height is from the floor to the ceiling. So you would take the length and multiply it by the width to get the area. Then, to get the volume, you would take the length, multiply it by the width, and then multiply it by the height to get the volume. Okay, next question, the critical thinking question. How can you find the area of a triangle? Pause this video, think about that. Remember, there are no wrong answers, unless you just don't try at all. So do your best, and then play it, and you can check your answer. Okay, so what you could do to measure the area of a triangle is you could draw squares that are identical in the triangle. So wherever you can fit, you're going to draw squares that are all exactly the same size. Now my picture is not going to have squares that are exactly the same size, but something like that. Then count how many squares you covered your triangle with. You could also draw the triangle on a piece of graph paper and then count how many boxes are inside that triangle. Now that's going to give you an estimated amount because you're going to have places like here and here and here where you can't fit a full-size box. But that's okay because we learned that when we find the area of weirdly shaped things or things that are not rectangles or squares, sometimes we do have to estimate the area. All those things on pages 422 and 423 told us ways that we can measure the size or shape of an object, which are some properties of matter. But there were other ones that we learned about. The next one is density. Density has to be measured differently because it doesn't really matter the shape or size of an object. It matters what it's made of, or the particles inside of it that tell us density. So what is density? A plastic ball floats on water. If you fill the ball with sand, it will sink. So that means you have a plastic ball and it floats on water. But if you fill that plastic ball with sand, it's the same exact shape and size, but now it doesn't float anymore. Why? The volume of the ball is the same, but you've changed its mass. Sand has more mass than air. So remember, density doesn't really matter size or shape. It's more about the mass, or how much the object weighs, like whether it's heavy or light. Mass times volume. The relationship between mass and volume is called density. Density is the amount of matter in a given space. So our next word is density. Whoops. Density. And density is the amount of matter in a given space. So how much matter is inside of that object? Is it heavy? Is it light? That will help you to determine the density. Scientists define density as the amount of mass in a unit of volume. Density describes how tightly matter is packed together. To find the density of an object, divide its mass by its volume. If the mass is in grams and the volume in cubic centimeters, then the result will have units in grams per cubic centimeter. Now that sounds confusing, but it's really not. Let's look at these pictures towards the middle of the book on page 424. So it told us that density describes how tightly the matter is packed together. Well, let's look at this cork. The density of cork is 0.24 grams per cubic centimeters. The particles are loosely packed. So we can see in that little cube where they have the little particles, we can see that they're not very close together. They can kind of move around if they need to. There's a lot of space between them. That means that the density is very low. So if you put a cork in water, because there's not too many particles inside of it, it's going to float. Then we go down to this piece of marble. The density of marble is between 2.4 and 2.7 grams per cubic centimeter. We can see that the particles are more closely packed. That means there are more of them. So that means this piece of marble is going to be heavier than that cork, and it may not float. It may be able to be pushed in the current of a river, but it's not going to float on the top. Then if we look at the key, it says the density of brass is 8.5 grams per centimeters cubed. The particles are tightly packed. We can look inside that cubic centimeter and we can see that those particles, there are a lot. They are pushing against each other. There is no room for them to move. There's no space between them. That means that that object has the most particles, so it's going to be heavy. It's going to sink right to the bottom, even in a flowing river. It's not going to be pushed very far. The more particles that are inside that cubic centimeter that we use to measure volume, the heavier it will be, the more dense it will be. Now let's look at the next page, density and buoyancy. The density of an object also affects its buoyancy. Remember, buoyancy is the upward force of a liquid or gas on another object. So buoyancy is how much is that water able to push on the bottom of that boat. Or it could be how much is the air able to push on that balloon. The higher the buoyancy, the more it floats. So a boat has buoyancy on water. However, it does not have buoyancy in the air because a boat is not going to float up in the air like a balloon. A balloon has buoyancy on both, filled with helium of course, has buoyancy on both water and in the air because it's going to float to the top. That air and that water are going to be able to push it up so that it can float. Float or sink. Consider cork and water. So cork, if you're not sure, is like that little picture at the top of page 424. The density of water is 1 gram per cubic centimeter. The density of a cork is 0.24 grams per cubic centimeter. Does cork float or sink? So if we look at that, we can see that the density of cork is lighter, is smaller than the density of water. Whichever object has a lighter density is going to float. So that means since cork has less density than water, it's going to float at the top of the water. The water is not going to be able to go on top of the cork because the cork is too light. An object floats when its density is less than the density of the liquid or gas in which it is placed. The density of cork is less than the density of water. So cork floats on water. Liquids can float on top of water too. If you've ever had you can do this at home. If your parents will let you, get a cup of water and get like a teaspoon of olive oil or vegetable oil or something like that. If you pour that teaspoon of oil on top of the water, it's going to float at the top because it has less density. You can also do that with dish soap. If you take a cup of water and you just pour a little bit of the dish soap, don't mix it up, just get a clear cup of water and pour just a little bit of dish soap. Make sure it's like blue or not clear so you can see it, and you'll see that it sinks to the bottom. Even though they're both liquids, water has less density than the dish soap, so the dish soap is going to sink to the bottom. Can you change the density of matter? If you add heat to air, the air particles move more quickly. They spread out more. The heated air is less dense. It rises and floats over the cooler, denser air. You've probably heard the term heat rises. So if you have an upstairs, your upstairs may be warmer than your downstairs at your house. That's because that heated air becomes less dense. It spreads those particles out so they are able to float above the cooler air where the particles are still packed a little bit more tightly. We can see this in the diagram at the bottom of page 424. We have a hot air balloon. We know that a hot air balloon has the same air inside of the balloon that it does outside, but there's like a flame that heats up that air. So as it heats up the air inside the balloon, the particles spread out and they move more quickly, so that means it's able to float. If we look at this picture, we can see that the air particles outside the balloon on the left there's more of them and they're a little closer together. Whereas we have that air particles inside the balloon, which kind of shows an arrow onto the balloon, there's less of them and they are more spread out. They are further apart, so that is why a hot air balloon is able to float. Make sure that you were listening. If you need to rewatch that, what I just said about that diagram, do that because you may see it again. Okay, so let's do the quick check. Remember, I will ask the question, you pause the video, write the answer in your notebook, play it, and I will tell you the correct answer. You can correct it if you need to or add to or whatever. Problem and solution. What is the density of a cube with a mass of 8 grams and a volume of 1 cubic centimeter? Oh, so we have to go back to what it said. And it says, if the mass, let's see. Oh, where'd my marker go? Here it is. Okay. It says to find the density of an object, divide its mass by its volume. It says it in the second paragraph underneath mass times volume. So if we want to figure out the density of a cube that is 8 grams, that has a mass of 8 grams and a volume of 1 centimeter, that means we need to divide its mass, which is 8, by its volume, which is 1, to get the density. So 1 goes into 8, 8 times 1 is 8, 8 minus 8 is 0. So that means the density of a cube with a mass of 8 grams and a volume of 1 cubic centimeter is 8 grams per cubic centimeter. Oops. So that means, if we're trying to figure out the density, that means 1 cube looks like that. It weighs 8 grams. Its volume is 1 cubic cubic centimeter. That means 1 cubic centimeter. Oops, I put square, but that's cubic centimeter. That means 1 centimeter. All of these sides are 1 centimeter. That means if you have a bunch of these, you would take this density. This shape right here has a density of 8 grams per cubic centimeters. So if you had a bunch of these, like 6 of them, and you wanted to figure out the density, you can multiply this by the number of cubes. Okay, the critical thinking. What should a hot air balloonist to go higher? Explain. So pause this video, write down your answer. What should the hot air balloonist? And why should they do that? That's what the explain means. Okay, so we know that warm air rises. So if he wants his balloon to go higher, then he needs to add heat to the air. So inside that balloon, he needs to pull that lever or that valve or whatever it is that sends a flame up and makes the air inside the balloon a little bit warmer, because warm air has less mass than cool air. Okay, go ahead and turn to page 426 and read with me. What is weight? Now you may be thinking, we've been talking about weight. It's mass, but they are different. Do you know your weight? Weight is another way to measure matter. Weight and mass may seem similar, but they are not the same. Mass is the amount of matter in the object. So it's how many particles are packed inside that object. Weight measures the amount of gravity between an object and a planet, such as Earth. So, our next word is weight. Weight measures the amount of gravity between an object and a planet, or a large body, because we can also say, we also have weight on the moon, a large body out in space. So the difference is, mass is how many particles or how much matter is packed into that object. So if we wanted to say the mass of a rock, that would be how much matter is inside this rock. If we wanted to say the weight, we would say how much gravity is between this object and the Earth. So that is the difference. Mass is the stuff inside the rock. Weight is how much this gravity is pulling on that rock. Our next word, gravity, is a force or pull. Pull is a synonym that we could use between all objects. How are weight and mass related? The force of gravity depends in part on an object's mass, because mass is going to tell us, is this object heavy or light? So weight does partially depend on the object's mass. The more mass, the stronger the pull of gravity. So something that has more mass, like a rock, is going to have a much stronger pull from the Earth than something with less mass, like a cork. We saw those particles are really far away inside a cork. So it's not going to be pulling as much, which means that weight is going to be much lighter. The stronger the pull of gravity, the more an object weighs. So something with more mass is going to be pulled. That gravity is going to pull a lot more than something with less mass. So that means it's going to weigh a lot more. Unlike mass, an object's weight is different on other planets and on the moon. The pull of gravity on the moon is about 1/6 as strong as on Earth. So an object's weight on the moon is only 1/6 of its weight on Earth. So that means if you were to go to the moon, your body is not going to change shape or size. The particles inside your body are going to stay the same. The difference is that gravity has less of a pull on the moon. So if you go to the moon, we're going to go ahead and answer the problem in solution down at the bottom. It says, how would you measure a rock's mass on the moon? The mass is going to be exactly the same because that rock is not going to change size or shape. The particles inside aren't going to change. Its weight will change because there's less of a pull on the moon. So its mass, whether you have it on Earth, a rock's mass on Earth and on the moon are going to be exactly the same. They have the same number of particles inside that object. However, the weight will change because the force of gravity on Earth is much more than the force of gravity on the moon. Do you weigh yourself with a scale? Mass is measured with a balance. Weight is measured with a scale. Ounces and pounds are the English units for weight. The metric unit for weight is the Newton. So you know pounds and ounces. However, the metric unit is a Newton. So let's look at this picture on the side on page 426. The caption says, an object with a mass of 1 kilogram, that means 1,000 grams, about somewhat similar to a pound, not exactly, but close, weighs 9.8 newtons on Earth. On the moon, the same object weighs just 1.6 newtons. So on the moon, there's less gravity pulling on it. That means everything will weigh less. However, does its mass change? No, it does not. Let's look at the critical thinking on the bottom of page 426. This one you can go ahead and answer in your notebook and then play the video to see if you are correct. What is the difference between a balance and a scale? And the difference is a balance measures mass, so it looks more like these things measuring on the side of page 426. That's more of a balance. Whereas a scale measures the weight. Okay, so that's it for that lesson. If you need to rewatch any pieces of this video or anything like that, go ahead. If you need to take a quick break, take a quick break, and then go ahead and get started on the independent practice. So if you get out your packet for Wednesday and go to the back or towards the back, you have your independent practice, and it's one of these diagram sheets. It is front and back. Remember, the answers can be either, you may have to look, the answer may be on the diagram, but you may also have to look in your book, just like every time we do these. The answers are not always going to be right here. Make sure you do the front and the back. It is, make sure you write in complete sentences, answer all the questions, and answer them fully. The page number, if you need to see a better picture, is written above the diagram where you can find it in the textbook. Okay, some of these, if you need to go back and rewatch parts of this video because you remember me talking about it, go right ahead. Okay, go ahead and do that, and then when you're done, you can take a break and you can work on the homework tonight. It's just the chapter 9, lesson 2 outline. Okay, make sure that when you get to the critical thinking question that you fully answer the question. Okay, good luck, and if that's the last one of the day, good job. If not, see you in the next video.